We're going to kick things right off in this first module by getting our project initialized, setting up our project structure, and doing some other configuration to make sure that we set up a solid foundation for our Express server that we're going to be continuing building on throughout the whole course. Before we start doing any work in this module, let's first take a step back and outline exactly what we want to achieve by the end of it. I've got some module objectives here that I just wanted to go through real quick. The first thing that we want to do is just set up our project structure and our project directories, and this just means creating some folders and some initial files in order to get started. Once we have that in place, we'll initialize a new node project, and then we'll go ahead and then we'll install some basic npm packages that we need. Mainly this will be Express.js as well as NodeMon. In addition to installing some of those packages, we're going to just set up a convenient npm start script for our development environment. And very lastly, we're going to set up a .env file to make sure that we have some environment variables that we can use throughout the build of our Express server. And we're just going to wire this up to a custom config file that we want to create in our project structure. And this will give us a nice way to manage all our environment variables in a very neat and modular way. So that's what we're trying to achieve in this first module. In the next lesson, we're going to get started right away. So I'll see you on over there. Cheers for now. The first task is to start setting up our folder structure for our project. Let's go ahead and open up a new terminal window and just choose a folder or create a folder where you feel comfortable storing your project on your local development machine. I've got a folder here already set up and I'm ready to go. Before we start writing any commands to create folders and files and that kind of thing, let's make sure that we aligned on the specific node version that we're going to be using throughout this course. So I can just do an nvm ls. If I run that command right now, you'll see that I have a couple of versions of Node installed here, but mainly my default version of Node that I'm using is version 20.10.0. If you don't have nvm installed, you can also just do a node-v, and that'll just tell you exactly which version of Node you're running on your computer. So go ahead and do what you need to do to install the correct version of Node. Once we're aligned with our Node versions, let's go ahead and create an outer folder structure that we can use to house all our files and folders for our application that we're going to be working on. So I'm going to go ahead and use this make directory command. I'm going to call my project node docker mongo. I'm just going to go ahead and hit enter there, and that's going to create a new project, and I'm just going to cd right into the node docker mongo folder that I've just created. And if I do a ls once I'm in there, and even an ls-a, you'll see that there's nothing in this folder at the moment, so it's just an empty outer folder. So within this folder that we've just created, let's go ahead and create a new subdirectory within here. I'm going to call this API, and this is going to be the folder that's going to store all the code for our Express server. I'm going to hit enter there, and we'll do an ls, and you'll see we've got the subdirectory in there called API. And there's just one more file that I want to create at this level. We will do a touch, and then I'm going to go ahead and create a docker compose file. So we'll say docker-compose, and then we'll just give that the extension of .yaml. Hit enter there and do another ls. All we have at the base of our project here is an API folder and a docker compose.yaml file. This file that we've just created is just going to be a part of the initialization for now. We're going to leave it empty. We're not going to touch this until a couple of modules time, but I just wanted to make sure that the main point is that we've got this outer folder structure here with the node docker mongo, and within it our API folder. It will house all our Node and Express code. Now that we have these two items set up here, let's go ahead and change directory into our API folder. And once we're in the API folder, we can go ahead and initialize our Node project. And we can do this by saying npm init, and then we can just use the -y flag. That -y flag just goes ahead and initialize a package.json file in our project. And so if we do a ls in this API folder, you'll see that we now have a package.json file. And this package.json file just contains this object that's been outputted here. So that -y flag just goes ahead and creates a very bare bones, very simple package.json. It doesn't take you through the prompt step by step to actually name everything in your, or fill in the details of your package.json. Now that we've initialized the Node project, let's go ahead and open up Visual Studio Code. And so go ahead and just make sure you change directory one level up so that you're in the node docker mongo folder. And then I'm just going to go ahead and run the code and then period. And this is just going to open up our project. in Visual Studio Code. Once we've opened our Node Docker Mongo project in Visual Studio Code, you'll see that we have the Docker compose.yaml file as well as the API folder. If we open up the API folder, we'll see that we have a package.json file. And if we open that up, we'll see we've got this JSON object here that contains all the basic bare bones configuration for our API. You can go ahead and fill this out with any of the information you want. You can fill out a name for your project. You can give it a description, an author, and change the license and whatever. So you can just go ahead and update any details that you want. But at this specific stage, all I wanted to do was make one change to the package.json. And that is I want to reference this type key here. And so if we, underneath the description and above the main key, I just want to reference this type key here. And I want to go ahead and change this to module. And the reason that I'm doing this is that I want to make use of all the new import and export syntax that are available to us since ES6. Now that we've made that minor change to our package.json configuration, the next step is to install two base packages that we want to make use of right from the get-go while we're building out our API. The first one is obviously going to be Express.js. Express is a really well-used NPM package to help us create Node HTTP servers. And the second one will be NodeMon, which will just allow us to set up hot reloading in our development environment, which just watches for any file changes. So any changes we make to our files or folders while we're writing our code, this is going to restart the server so that we don't have to keep running the commands to start our server every time we make a change. So to install this, we have to just make sure that we are in the root of our API folder. In a new terminal, if we locate it at the parent directory of our project, we should just cd into the API folder. Once we're in there, just make sure we've got our package.json. Once we're in there, we can do an npm install. We'll just reference the Express package there as well as NodeMon. I'll hit enter and wait for that to save. Once that command has been run, those two packages have then been installed into our project. We've got our Express package there, as well as the NodeMon package that's been added. And so to get started, the first thing I want to do is create a brand new folder. I'm going to just call this source, or SRC for the abbreviation for source. I'm going to add that folder, and this source folder is going to contain our specific code related to our API. So at the root of this source folder, we create a new file, and I'll call it index.js. And this index.js file is going to act as the entry point into our application. For now, I'm just going to leave a to-do comment here. This comment will remind us to start our HTTP server, but we haven't got the code to actually do that, so we'll just make a to-do now, and we'll get back to this once we have written the code to set up our server. And something I like to do is just do a simple console log when I'm setting these things up, just to make sure that everything's wired correctly. So let's just do a simple console log. We'll say testing index.js. Let's go ahead and start up our Node server. So in the terminal at the root of our API folder, we can just run node, and then we just need to reference the source folder and then this index.js. If I hit enter there, you'll see that we get that testing index.js console log, so that we know that our entry point into our application is actually being run in the correct way. And so there is one quick change we need to make to the package.json file. And under the main key, just so for the sake of being correct here, our entry point in our Node application is actually housed in the source folder, and it's this index.js. And that's the entry point to our file. So we'll just make sure we save that in the package.json file. So we've tested that our index.js file is being executed when we initiate the node run command. The next thing I want to do is just set up a npm script that we can run, and we've installed NodeMon, and we want to make sure that it's working for us right from the get-go. So in order to do this, we can just remove this test script that was dumped in here by our npm init command, and we can just go ahead and create a new key within the scripts object. And I'm just going to call this start:\dev. And that command is just going to be used to start our development environment. And then we can go ahead and just to build this up, we'll just first put the standard node command to start our project. So we'll say node source index.js. And this is the command that we literally just ran in the terminal. And now instead of just running the node command straight at the root of our API, we can say npm run start dev. Once I run that command, it goes ahead and it starts our application, and it runs that console log that we have that's sitting in our index.js file there. All we need to do to get NodeMon running is, instead of referencing this node command, we can just reference NodeMon, and we just run it in the exact same way. I'm going to hit save there. We can run the same command. We can say npm run start dev. And if I hit enter now, you'll see the output looks slightly different. We've got some additional output that's coming from the NodeMon package, and it just goes ahead and it says starting the node project at the route that we've specified. And you can see the blinking cursor is sitting there. Just to demonstrate how this works is whenever we make a change with any files or folders within the source folder here, you'll see that these changes will reflect. Once I hit save here, these changes will reflect immediately because that command to restart our project will be run. So this is going to be very handy for us. Instead of rerunning those commands to start each time we make a change, it's just going to do it on the fly. We've done the initial work to build out some of our API. We've got NodeMon working. We've got a nice npm script that we've created. Let's take a short break here and we'll continue in the next lesson. I'll see you over there. Cheers for now. We've got our node project running our code that we've written in the index.js file. At this point, it's not doing anything at all interesting. It's just writing out a console log. The next setup task is now to implement a basic Express server. And so the way we're going to do this is in our source folder, we're going to go ahead and we're going to introduce a new folder into the project. And I'm going to go and call this lib. So that's just short for library. Within that lib folder, we're going to have a new file, and I'm going to call this server.js. And the idea with this file is that any code related to our HTTP server that we're creating, in terms of initializing it and configuring it, this should be housed within the server.js file. We're going to go ahead and implement the very basic code to start an Express server. So we'll import the Express library from the Express npm package that we've installed. Then I'm going to go ahead and I'm going to create a constant here, which is going to be called start server. And so this function's task, and I'm using an ES6 arrow function here. This function's task is to make sure that our HTTP server is up and running and listening on a specific port. I'm just using that export keyword so that we can invoke the start server function in the root of our project, which is the index.js file, but we'll get to that in a moment. For now, let's just use our console log and wire this up to our entry point of our application. So we'll say start server function running. You can go ahead and save your work there and then head on over to the index.js file. Right, so we can go ahead and remove this comment, and now we can import our start server function that we've just created. So that'll be import start server. That'll be from that lib folder we've just created, and we'll reference the server.js file. Once we've imported that function, we can just go ahead and then invoke it, and that should now run that console log that we've just created. So I'm going to go ahead and hit save here. And so in our console logs, we can see we hit this first testing index.js. Next up, we see the start server function running. So now that we've done that, we can just go ahead and remove this console log and clean our work here. And so all that our index.js file is doing is it's invoking this start server function. But down the line, if there's any other configuration or initialization that you need to do that's outside of the HTTP server, you can run this in the index.js file. And for now, we've kind of abstracted this work out to the server.js file, and so we can begin implementing our Express server in here. Now that we know that this start server function is connected to the entry point of our application, I'm just going to go ahead and remove that console log. Let's get to work starting implementing our Express server. So I'm going to create a constant here. I'm going to call this HTTP server, and that's going to be an instance of Express. All we need to do is reference Express here, which is actually just like a higher level function. And if we invoke it, it's going to return a whole module of code that's going to contain all the methods and properties that we need to work with our Express server. So once we invoke it, that Express function, once it's invoked, is going to return an instance of Express, and we're assigning it to the value of HTTP server there. To start up our server, we're just going to set up a try catch block. And I'm just going to handle the error case for now. We'll just throw a new error if we do get an error while we're trying to start up our server. In the try block, we'll just reference this Express instance that we've just created. And then there's this method on the Express instance called listen. And this is just going to create a very standard node HTTP server that's listening on a specific port. So the arguments that go into this listen function is a port, which we can send through. You can see it just takes in a port and a callback. The port will be the type of number. So I'm just going to reference a port 3000, and then it takes in a callback. So I'll just set up an arrow function there. We can just put a console log here, and we'll just say something like server running on port 3000. So once I hit save there, you'll see NodeMon will have restarted our application. We've got a server that's running on port 3000. With that very basic setup that we've just implemented here, we've got a very basic Express server listening on port 1000 and it's ready to receive traffic. This is really all you need to do to start up the server. And this will act as the foundation for the rest of our course. And we're going to build on top of this and get our REST API working in a much more sophisticated way. So let's take a short break here. We've written some code, make sure that it's all up and running correctly. There's no errors in your console, and just make sure you're getting that console log saying that the server is running on port 3000. In the next lesson, we'll start looking at implementing some environment variables. So I'll see you in the next lesson. We'll start implementing that. Cheers for now. We have our very basic Express server that's set up and running on port 3000. Now's the perfect time to start implementing some environment variables in our project. As the name suggests, the environment variables are a super important thing in our project. It's going to allow us to create different variables for the different environments that our application is going to live on. So for now, and in this project, we're going to be working in a development environment. For example, the port is going to be the first variable that we want to introduce. We've hard-coded the number 3000 into the port that we want our server to listen on. That may change in a staging environment or a production environment. We just want to rather reference a variable that comes from our environment and inject the variable in, and then through some type of configuration that gets injected into the project, that variable can change depending on what needs to happen. So in a development environment, we can run it on port 3000, but in the staging environment, it might need to run on 9000. And in a production environment, it might need to run on port 80 or port 8080. So instead of hard coding this in our application, we can just set up our environment variables that is sorted across all the environments. Because we're using a version of Node which contains a change that Node introduced to allow us to wire up a .env file straight out of the box in terms of what's available from Node, we used to have to use packages like .env to set this up. Now that we're using a version of Node that allows us to set this up from right out of the box. And so let's go ahead and implement this, and let me demonstrate exactly what I'm talking about here. If we head on over to our package.json file, the way we can do this is in our start dev command after nodemon, we can just create, and this flag we can call this env-file, and then we can just use the equal sign there to assign the value of where our .env file is stored. So we haven't created this file just yet, but it is going to be created in a moment. So for now, we're just going to reference .env, and then we'll say .development. The reason I'm using a .development extension on the .env file is this command runs a development environment. And so we want to make sure we have a .env file that's specific for development. We could introduce different commands saying start staging or start prod, and those could reference the different environment files that are relevant to that specific environment. So I'm going to go ahead and save this work here. You'll notice any changes we made to our package.json doesn't trigger nodemon, and that's because nodemon is only listening for changes in the source/index or in the source folder. And this package.json is actually at the root of our API folder. So let's go ahead and create this .env file. So we'll go ahead and create a new file at the level of the API, and we'll just call this .env.development. I'm going to go ahead and hit enter to create that file. Once this file is created, we can just use this to store all our specific environment variables. At this stage, we only really have one variable that we want to work with, and that's the port on which we want our server to listen on. And so we can just go ahead and create this key value pair here using the syntax. We can say uppercase port, and we just use that equal sign, and then we'll reference the value that we want to be assigned to that port. Very simple stuff. That's the only thing that this .env.development file is going to contain. The next step is to be able to grab a hold of this variable that we've just set up here. In order for these variables to be available to us now, we're going to actually have to manually restart our server. Because we've now made changes to our start script, we actually need to rerun the script to ensure that this .env file that we've just created gets injected into the Node runtime. So in your terminal, you can just do a Control-C and stop the server that is running. And then we can go ahead and rerun the npm run start dev command. And when you run it, you'll see that there's this additional flag that's being passed in, and in theory we should have access to that environment variable that we've just created. So to test this out, we can head on over to the server.js file, and right underneath the HTTP server, let's just do a a quick console log, and we'll say port from .env file, and then we'll use some string interpolation. And the way we're going to grab a hold of this now is we're going to reference the process, which this is available to us through the node library. It's a reference to the node runtime that's running, and there is this key that's available to us on here, which is .env, and this is going to be all the environment variables. And so that command that we've just set up is now kind of linking the environment variables that we've set up in our environment file, and it's making it available to us on this process.env. And so we can just reference the port that we've just created, and remember that it's in uppercase, everything's in uppercase here. So just make sure it's in uppercase there. And when I hit save now, and nodemon refreshes the server, we should see a console log printing out the value of our port. So you'll see we get that port from .env file, and it's saying 3000. Now we've got a way to dynamically grab a hold of this port. Instead of hard coding it, we can just set this to a variable. So we can go ahead and delete this console log. And I'm going to create a new constant here, and I'm just going to call this port, and the port can come from process.env, and then we'll just reference the port variable that we've created there. I'm going to go ahead to save there, and now instead of hard coding this port into the .listen function there, we can now reference the port variable we've created, and instead of hard coding it in our string, we can use string interpolation and just pass that port in there. I'm going to go ahead and hit save to validate that our server is still running, and it is indeed running on port 3000. And just to demonstrate how this will work is if we go ahead and change this value in our .env.development file to 9000, we can save our work. In the terminal, we'll just have to rerun the server to inject the new variables into the project. So we'll say npm run start dev. Our server is now running on port 9000. So we've now successfully set up our environment variables, and it's now connected to our node project. Let's just go ahead and change that back to 3000, because that's what we're going to be using in our project, and we'll rerun our start dev command, and we've got our server running on port 3000. As our API grows, we can continue adding more and more environment variables to this .env.development file, and it'll be available to us through the node process, and we can then reference any of those variables into our application. So we're making really good progress here, really good work so far. Let's call it a wrap for this lesson. In the next one, we're going to do one last tweak and add a custom config file to our project. And this is just going to act as a layer in between the node process and our application. But we'll see what that's all about in the next lesson. So I'll see you on over there. Cheers for now. Now that we've wired up the environment variables and set that up in our node project, there is one slight refactor that I want to make to our project. And at the moment in our server.js file, we're just referencing this process.env.port. There's nothing wrong with doing this in general, but over time, let's say we've got 20 environment variables that we have in our environment variable file. And whenever we want to reference it, we're going to have to type out process.env over and over. And I think it's going to start making the code a little bit unneat, and it's just like kind of duplicating a little bit of code everywhere within our application. So let's think of a way that we can just set this up in a neater way. As well as there's a second point here is, for whatever reason, if the port is not available to us through the environment variable, and that could happen very easily because these .env files are normally not committed to source control. When someone creates a new folder here, they might forget to create a .env file locally, and these variables then won't be available. So to simulate that, I'm just going to delete this port, and I'll just save our work here. In a new terminal, you'll see that we get the server running on port, and it's undefined now because there is no value. And so if we pass a value of undefined into this HTTP server, the server is not going to be initialized. And so these kind of things can happen. And so we can think of a way to make our code neater, as well as to implement some fallbacks onto some of these variables in case the variable's not coming from the environment file. So let's just go back to our .env file and save our work there. And let's go ahead and rerun our API just to make sure that everything's working. The way that I want to do this is very simple. In our lib folder, let's go ahead and create a new file. I'm going to call this config.js. And this file is going to house an object that we're just going to export as a default. And it's going to contain keys and values related to all the configuration in our API. So by the end of this course, we're going to have built this up, and all the values for our whole API will be sitting within this config file. And so let's get started right away. We can say export default, and I'm just going to export a straight object out of here. And the way this object can work is we can just reference a key for every part of the config that we want. So this first key, we've been referencing this port, so we'll just say port, and then we'll assign this to the value of process.env, and then we'll reference that port. So now we can make use of this conditional OR operator to provide us with a mechanism to have fallback values in case the variables that come from the environment are not detected. And so I'm just going to set a fallback value here of 3000. So basically this key of port is this expression that we set up here. It's first going to try and get the value of port from the environment. If it's a truthy value, it'll just return that value and assign it to the port. Otherwise, if it's undefined or any type of falsy value, it will then fall back to this next side of the expression on the right hand side, and it'll assign this value which we set 3000 to the value of port. So in this way, we've got just a little bit of safety in case the environment variable hasn't been set up. Now all we need to do is in our server.js file, we can import our config from this file that we've just created. So that'll be config.js. Now instead of referencing the process.env.port, we can now just reference the config.port. I'm going to go ahead and hit save here, and you'll see in our terminal we keep getting that server is running on port 3000. And let's go ahead and just test this out real quick. Let's make one change. Let's say that the default port should be 9000 if it doesn't pick something up from the environment. And in our .development file, let's just remove this port here and go ahead and save your work. And if we rerun the server, I'm going to kill our server and then just rerun it. You'll see that instead of throwing an undefined or an error or saying that the port is listing on undefined, it's now fallen back to that value of 9000, which is coming from that logical OR expression. And so in this way, Node didn't detect any port variable because we deleted it, and so it just fell back onto 9000. And so that's a pretty cool mechanism that we will make use of throughout our API. I'm just going to go ahead and reset this. In the .env file, we can just reset that back to 3000 and restart our server. And you'll see now that we have our server running on port 3000 and we've wired up this configuration mechanism into our API. I think we are good to go. We've laid some very solid foundations. We've done some of that initialization and initial configuration of our API. And with all of that work that we've just done, that is a wrap for this whole module. So well done on making it this far. In the next module, we're going to start turning our attention to setting up Docker in our API. So that's going to be some really cool work we're going to go through. Looking forward to working through that with you. I'll see you in the next module. Cheers for now. Before we start writing the code to set up Docker in our application, we're going to take a moment to just work through some definitions and some conceptual understanding of what Docker is. If you've worked with Docker before and you've got a good grasp of this, you can just skip ahead to the next lesson where we'll be writing the code to set up Docker. If you want a refresher or you don't know much about Docker, this is going to be just a simple, quick overview, nothing too intense. Docker can be quite an in-depth topic, so this is not a deep dive, just a quick overview, just so that we can understand what we're doing with it in our application. Earlier on in my development learning curve, when I first came across Docker, was definitely one of those tools that I couldn't quite grasp initially, sometimes conceptually, and it was a bit too abstract, but once I realized the utility of it when it came time to deploy code and working in multiple environments, I learned the utility of Docker, and it's an incredibly useful tool, and it is one of those tools that's widely used in companies of different sizes. I've definitely used in my own projects as well as professional projects that I've worked on. So take the time to learn Docker. It's super, super useful. So if I had to explain Docker in 3 words, I would be simplifying code deployment. You can think of Docker as a tool that's going to wrap up your whole application, your whole code base into a very neat package. And this package in the Docker world is called a container. And this container that will house everything that your code will need to run, plus all the settings, all of the configurations and dependencies. Every single thing that it needs, it'll be housed in this container, packaged into a neat little bundle. So once it's packaged up in this container, the question is like, why does this become so useful? So if you've ever had to work on varying different environments in terms of development, so whether it's on your local machine, which is a Mac, or another machine, which is a Linux machine, or else in a cloud environment on different servers, you understand if I had to set up Node, for example, on my local machine, I'm going to have to do the work to do that and get the right version. And then if I move over to Linux, that installation process of Node is completely different. It's a different operating system. So that can become a bit tedious when you want to quickly like port over from one operating system to another for whatever reason. If we have this base understanding of Docker uses these things called containers to package our code into neat little bundles, we can package our code in a way that is configured and can work in the exact same way on every different environment that you want to use that has Docker on it. So whether it's your local machine, a colleague's computer, or in a complex cloud environment, once your code has been packaged in a specified way where you declare how you want it to run, it'll run in the exact same way on all these different environments. And so this provides a level of universality to your application. Instead of trying to, in every environment that you want to run your application on, configure that specific environment, you can just configure your container in a certain way, and then it will universally run on the different environments. And the magic of Docker is that it takes care of all of this hard work, the configuration, the complexity behind the scenes, and Docker provides us with a very easy way to kind of configure this and set it up for our own application. And this allows us as developers, especially like kind of just application developers, to focus on creating our applications, writing our code for that, and not getting too stuck into the infrastructure side of things and deploying our code and configuring it on different machines. So we've spoken about this idea of containers, and Docker uses containers, and this is a central concept to the world of Docker. As we've been talking about, containers allows us to standardize our code deployment. You can think of containers as the Docker's universal method for shipping code. And so the analogy here is the shipping containers that we see in the global shipping system. And these giant shipping containers were an innovation that was created in the shipping industry way back in the days. And before these containers existed, shipping companies just received the goods that needed to be shipped from the different customers that were shipping them. All the goods came in different packages and different sizes. As you can imagine, this made an incredibly inefficient system for packing these goods and packages onto the ships. And that meant obviously any inefficiencies will lead to a higher cost, and so shipping was quite expensive until someone came up with the idea of modular universal containers, where the customers who were wanting to ship their goods would pack their boxes and their items into the container, and then so they were in charge of setting up their container however they wanted to, and then the shipping company will just stack the containers on their ship in a nice neat row. This innovated a much more efficient way to pack goods onto a ship, and then over the years obviously this reduced the cost of shipping, and it just made the whole system a lot more efficient. So I think this is a great analogy for understanding Docker containers. You can think of that container as a universal method for shipping your code. So Docker provides a container where you can stuff and pack your code however you want to in your own way into that container, and then once it's packed and locked, that container can be deployed onto different environments, consumed in whatever way that is necessary on those different environments. So it provides a level of universality, a level of standardization. Just as the shipping container revolutionized the shipping industry, Docker has provided a lot of innovations and allowed us to do some really cool things in the development world. So we can agree that the Docker containers provide a standardized unit for our software. So no matter what our code looks like, what specifics are we using, Node, Python, Ruby, whatever it is, however we want to configure it, even in the Node, if we're using different versions, everything is going to fit into that container because we declare it that way. And once it's in there, it's kind of standardized. And that Docker container is going to be fully prepared to kind of be sent anywhere and run anywhere. Obviously, you'll need Docker on the operating system that you want to invoke that container. Essentially, and in a nutshell, these containers create a lightweight and self-contained way for us to ship our code. And sometimes I do think this might be a bit hard to grasp if you're completely new to Docker. Like, so what is the utility in this? And I think in summary, we can just say, like, we can pack our application into a Docker container, and then we can run that in any environment without compatibility issues and headaches that you would usually face. Why have we decided to use Docker in our particular tech stack? Because Docker allows us to containerize our application and let it run on different environments. This allows us to create and mimic a mini version of a production environment, like right on our local machine. And so this makes testing and development very, very convenient. And for us specifically, where it's going to be super handy is We're going to be working with MongoDB. With MongoDB, you can obviously install it locally on your machine and set up an instance of MongoDB and interact with the database there. However, when you move this over to a staging environment or a production environment, you'd obviously have either Mongo set up on your server, but that's not like the recommended way. There's services like Mongo Atlas, which would be a dedicated hosted instance of MongoDB, and that's super convenient and useful for production environments. But however, that does come with a cost. And so in a development environment, you don't really want to be connecting to your Atlas instance. Well, obviously, everyone can make that decision for themselves. But for us, we don't want to go and sign up for Atlas, put in our credit card details, all of that. We just want to create a local instance of MongoDB. So we can use Docker to package MongoDB in an isolated container. We can mimic a production-like environment. It can mimic a cloud database. And it also just kind of spins up Docker in a self-contained unit. All the files and stuff are in there. And so it makes it nice and neat and clean. And we can also leverage things like volume mounting and networking just to allow us to persist data and use Mongo in that containerized to really make a super convenient way to spin up a database locally. I think we've covered a basic understanding of what Docker is and why it's useful to us. We've just gone through a few slides there. And so enough of me just talking about that. Let's get hands-on and start turning our attention to setting up Docker on our local machine. So that concludes this lesson. I'll see you in the next one where we'll take a look at installing Docker on our local machine. So I'll see you on over there. Cheers for now. Hello and welcome back. The very next task for us in our application is to set up Docker and get it configured within our code base. In order to do this, we need to ensure that we have Docker on our system. To check this, you can run this command in your terminal. You can say docker -- version. And if you hit enter and you get anything like this where it says ZSH command not found Docker, that means that Docker is not installed on your system and those CLI commands are not available to you. I'm going to take the time to go through how you would install Docker. It's a very simple, straightforward process. You can go to docs.docker.com/get-docker and you'll find yourself on a web page here where it's got all the information that you need to get Docker. You can obviously choose which environment you're working on. I am working on a Mac, so I'll choose install Docker for desktop on Mac, and then go ahead and just choose which chip you're using. I'm using an Apple Silicon chip. And so you can just go ahead and read through the system requirements, check if you've got everything that you need in order to use Docker. And if you scroll down a bit further, you can see the instructions on how to install Docker desktop. And so when you install Docker desktop, it's going to install the Docker engine and everything else that you need. So it really is become quite a simplified process. And so essentially there's two ways that you can install Docker. You can install this interactively by clicking on this one of these buttons here to download the DMG, and then you can just go through the instructions to do that. Otherwise, once you've downloaded the DMG file, you can install this from the command line. So the easy way to do this is just interactively, but obviously you can do this however you want. Just go ahead and download that DMG file. Once that is finished downloading, we can continue. Once the download for Docker has completed, you can double click on that .dmg file. You can just drag Docker into your applications folder. And once that's done, you can just click on Docker in your applications just to open up the application to run. So when you first open the Docker application, once you've downloaded, you just come to the service agreement page. They have some terms about bigger businesses who are exceeding a certain amount of revenue that requires a paid subscription, but for personal use, small projects, small businesses, and educational purpose and that, it's free. So you can just accept those terms. And once you've accepted that, you can head on to the next section. It just asks you for some configurations. You can just go ahead and accept the recommended ones. And it's going to ask you a short little question here, and so you can just fill that in however you want to. So once that is complete, you'll see the Docker desktop app has then launched, and you get this panel here in front of you. You'll also notice that this Docker icon menu here, where you can kind of access any of the other menu items that you need to. You'll have noticed that I've been logged in with my Docker Hub account, and so if you haven't got a account, you'll just need to create one and create an account and a password in that. And once you've done that, you'll be able to log in here. A quick tour of the Docker desktop app. You'll see in the top right here, you'll have your account button, which just allows you to access your account settings, and that'll take you to the web app where you can sign out. Otherwise, you can access the settings here, and there's going to be a whole lot of settings that you can set. Like under general, you can set the theme, all of those good things. Otherwise, the rest of this stuff, unless we're going to do a deep dive, these are not that applicable. You can access your settings from here, and on the far left, you've got this vertical menu where you can access your containers, your images, and then you can see any volumes. That will be the most important things that you will be using, and like this will all make sense once we start working with our containers and images. For now, you'll see that this is all empty. So on the images section here, you'll see you have a local tab, and this is going to just list any of the images that you have created locally. Otherwise, you can access some of the images that are available through the Docker Hub, which is a library for Docker images that are available to the public. So we'll go through all of this once we actually start creating our own containers and images. For now, just one important thing is down here, you can see there is some stats here for you, how much RAM is being taken up, CPU, disk, and all of that stuff. You can also see that the Docker engine is running, and so that just displays the status, and you can go ahead and turn that off if you wanted to, and that will just quit Docker Desktop, pause it, or restart the Docker engine. So that is the Docker Desktop app, which is super helpful. Obviously, you're going to be working with Docker through the terminal as well. It's just a nice visual way to see what's going on. Then one important note is in future, if you want to use Docker in any of your projects, just make sure that Docker Desktop is running, and you'll see there's that little green light. So you got to make sure that the Docker engine is available. So I'm going to go ahead and minimize this. So to verify that Docker's been installed, you can verify that in your terminal. I'm just going to say docker -- version. And you'll see that we've got the Docker version outputted here. And so this is a way for us to validate that the installation was successful. Docker's running, and now we can make use of it in our application. And so that's it for this lesson on installing Docker and a quick walkthrough. Let's take a short break here, and in the next lesson we can start configuring Docker. So I'll see you on over there. Cheers for now. In the last lesson, we've done the work to set up Docker on our local machine. Now we can turn our attention back to Visual Studio Code and our code base to get Docker configured and running. We can start building our very first images and containers. Before we do the work to start configuring Docker, I just want to make sure that our API is running smoothly and there are no problems. So if I run npm run start dev, I see that the server is running on port 3000, everything's working correctly. So I'm going to just hit Control-C there to kill the server, and I'm going to Command-K to clear out the terminal. Now that we have a bit more space, we can just validate that we have Docker running. And so I'm going to say Docker version, and we have that version that's outputted there. I'm running 24.0.7 at the time of this recording. And so we know Docker is set up there. Let's turn our attention now to Visual Studio Code. And what we're going to do is in our source folder, the first thing we need to do is create a Docker file that's going to contain all the configuration needed for us to make use of Docker or package our code base into a Docker container. In the root of the API folder, I'm just going to go ahead and create a new file, and it's going to be a Docker file with a capital D, and I'm going to hit enter. Just make very sure that you have this Docker file at the root of the API. It needs to be on the same level as the package.json. A Docker file is just a simple text document that contains a set of commands that you're going to set up that Docker is going to use to containerize your application. And so the syntax is very simple. It kind of uses command value syntax, and so the commands are like keywords in Docker, which the convention is to use uppercase for, and then the values will be your specific values of how you want to configure things. So let's just run through writing out the configuration, and then we'll do a quick explanation of each command step by step, as well as some of the syntax. So the first thing that we want to do is use this from keyword. And this specifies the base image that we want to use for our Docker container. And so I'm going to use a base image called node 20 Alpine. And so if you head on over to Docker Hub, Docker Hub is a public library where Docker images are accessible. And so you can go and search here for Node. And if you hit enter there, you'll see that first result that should come up here is this Node.js Docker official image. You can take a look at that real quick. All these images have different sets of tags, and that correlate to the versions of Node. And so at the time of this recording, the latest one here is 21. We're going to be using this version here, this Node 20 Alpine. The Alpine just refers to a very lightweight version of Linux that is like just contains the absolute bare necessities. So we have that from command, which is setting up the base image. Then we're going to use this command work directory, which is going to set up the current work directory that we want to be working in. So I'm going to say user/source/app. And the next command that we're going to use is this copy. And so over here, what I need to do is copy over the package.json files. And so I'm going to use this expression here with a wildcard. and that's just going to ensure that we copy both the package.json and the package.lock.json files. And in this syntax kind of uses the source destination, so it's going to copy from this source, and then what we want to do is just copy that over to the root of our working directory, which we've just defined there. And then next up, we're going to invoke this run command. We're going to say npm CI only production. And even though this is a dev environment, we are using this CI only production command. I will explain shortly why we're doing that. Basically, that's just going to run an npm install on our packages, which would now be available here because we've just copied over the package.json. And then right after the run command, we want to copy. We're just going to copy everything from our API folder here and then put that straight into the working directory. And at this point, we have everything loaded up into our working directory of our base image in our container. And so the last thing we can do here is use this command, or the cmd command. And then that's going to take a square brackets and then a comma separated list of strings for each item in your command that you want to run. So we've been running our application with this command here called npm run start.dev. And then that's related to our command in our package.json. So all we need to do is just break that up and say npm and then run. And then the last one there will be start dev. With that, we have kind of configured our Docker file to define how we want our container to look like, or what we want our container to look like rather. With that, we've got our basic Docker files all set up. So we did a bit of typing there and very quick explanation, but let's just walk through this Docker file step by step and just have a clear understanding of what's going on. If we take a look at line number 1 here, so this syntax is, we have the command here, which is a keyword that we can use in Docker. It's that uppercase from, and this from command is going to specify the base image that we're going to be building. So following the command that we write here, we can specify which image we want. And in this case, we want to specify the Node 20 Alpine base image from Docker Hub. And this is a public available image. So once that layer has been set up, the next command that we'll take a look at here is this working directory. So the command here is work directory. So that's just going to set up a current working directory for our Docker, or like for the Docker layers here. So the value that we pass in here is /user source/app, and that's, you can kind of set that up however you want to. And once we have the working directory set up, the next command that we have here is we're making use of this copy command. And as the name suggests, and like with any ZSH or bash, it's like going to copy some files or folders. So the value that we pass in here is going to have 2 parts. This first part here is going to be the source of our copy command. And so we specified here package wildcard.json. So it's going to search for all the files in our current source folder. And because the Docker file is at the root of the API, this is going to be where it's going to search. So it's going to search through, it's going to find the package lock.json as well as the package.json. It's going to copy it over to our destination, which we've just set as the current working directory, which obviously then relates back to this current directory that we've set up. Next up, we have this run command. So next up we have this run command, and that's going to execute this command that we've passed in here. So that will then execute this value that we've passed in here. And so we've passed in npm CI only production. And so this command is going to install all our dependencies in our project with the exception of any dev dependencies that we declare. This is a command that you generally use in production. It's generally faster and quicker and avoiding all the unnecessary bloat of dev dependencies. And the reason I'm using it here is that we don't have any dev dependencies in our project. And so we can just go ahead and use a production build in our local environment. And in more complicated code bases, you generally have a Docker file. A possible way to do this is set up a Docker file for your dev environment and one for your production environment, and then you could change these different commands. But that's too complicated for what we're trying to do, and we're just going to make use of this command that we've put in here. We could have just very easily said npm install and leave it at that. Next up, we have this copy command again, and so the reason we specifying this after the npm install, we'll have our node module. So if you think about this, at this stage, once we've created the working directory and we've copied the package in JSON, we've just got an empty folder there with 2 of these files. So it'll be the package lock and the package JSON file. And there's nothing else in the directory. And so what we want to do is copy everything from our source So that'll be that period here will relate to everything in here. So that would include all our other code that hasn't been copied at this point in time. So that'll be whatever's left to copy in here, and then that'll then be sent to the destination, which is our current working directory. And so all our application code, as well as the new node modules that have been installed, then will be copied over into here. And the last command in our Docker file is this cmd command, which provides the default for executing our application, or for executing our application within our container. So when the container starts, whatever we define in here is going. So when our container starts, whatever we defined here will then be run as soon as it started. And therefore it's going to run this npm run start dev, and that's going to spin up our Node Express server. All right, so we did a bit of typing. We did a little bit of an explanation there. Let's take a quick break here. In the next lesson, we will start playing around and building this doc file into an image and playing around with the container. So I'll see you on over there. Cheers for now. Now that we have our Docker file set up in our API folder, we can go ahead and start running this and seeing what the output is. I'm going to set up a command here that is going to go ahead and build our image from our Docker file configuration. Let's go through this right now. We're going to use the Docker command in our CLI here to reference the Docker engine. I'm going to use this command called build, and it's going to take in a flag -t. The next bit here is going to be some naming that we're going to set up. So I'm going to say my app, just for the name of our application, and then we're going to say /, and then this is going to be the name of our image. And so I'm going to say Express API, and then we're going to put a colon here. Whatever comes after this colon is a tag that we can create. So I'm going to say latest -dev, and then the last part of this command, which is important, is this period. And so I'm just going to delete the period here just to show you what's going to happen if you don't include it, because I've made this mistake many times. Sometimes I forget about it. You'll see you're going to get this error, docker build x build requires exactly one argument. So if you ever see that, that's the clue, just to say that you forgot one of the arguments in the command. But just make sure that you specify the dot, and all that dot is doing is just saying it needs to look for the Docker file in the current directory that you're in. So if you are located in the API directory, you should have your Docker file in there. And so all you need to say there is dot. If it was in a subdirectory, then you could say subdirectory, whatever, and then it'll find it within there. But we just need to include that dot. So with that command, I'm going to hit enter here, and let's see what happens. Right, and upon successfully running that command, you'll see there's a whole lot of output that gets dumped out into your terminal. And this is just like as Docker goes through and executes each one of the commands, it's going to just give you some metrics on how long it took and some other information. If you take a look here very quickly, the first kind of thing that's interesting to see is that it transfers the Docker file. And then there's this important step here, which looks like the auth step for being able to access the Docker Hub registry. It's vitally important that you've got an account and set up with Docker and you signed in. If you're pulling from the public registry, it needs some kind of authentication there. So once authentication is complete, we have this next step here, which is 1 of 5. If you count in our file, we've got 1, 2, 3, 4, 5, 6 commands. But this last command is the one that gets executed when the container has started. So like in terms of building the image, we only really gonna Docker's only really gonna care about these first 5 commands. If you see, we've got step 1 of 5 here. You can see it's pulling from the Docker directory. It's pulling the Node Alpine version, and that obviously takes a while because there's a little bit of downloading to do. The next step here is our working directory, and that sets it up according to our definition that we have over there. And then the next step is copying the package.json, and that's going to relate to our line 5 in our Docker file. And I'm sure you're starting to catch the drift here. It's just interesting to see how each one relates. You can see whatever we specified has been run programmatically in here, and the last step is just that copy, and that takes care of the rest of our commands. And once that's done, it writes the image, and then you can see this last step here. It names our Docker image the way that we specified in our command. So now there's a few ways we can take a look at these images. So I've cleared some space for us to work here, so we can use Docker images, and if I hit enter, it's going to output a list of all the images that we have that have been built. And so you can see we've got my app Express API with the tag latest dev. It creates an image ID for it, and then that's 4 minutes ago it's been created, and that, as well as that, gives you the size. So if we go ahead and open Docker desktop. I just want to show you this so that you can see how this all works, and then you can choose what's the preferable way for you to do. So if you go to the images here and then to the local tab, you'll see that this My App Express API, exactly as it's listed out here in your terminal, is also available from the Docker desktop app over here. There's a tab here at the end for actions. This play button says run. And so what that's going to do is it's going to go ahead and run your Docker image, and then that will create the container. As the container starts, it's going to then execute that command that we've written. So we can do this from the terminal or Docker desktop. I mean, we can go ahead and do both. Let's just do it from Docker desktop here and see what happens. You can see when you click run, it gives you some additional options, and I don't want to worry about any of those right now. We can just click on run here. And you can see there's a new instance that's running here. Very interestingly, you'll see the logs that come out here. We've got our server running on port 3000. And so as soon as this container started, we've got the start dev command that was run. You'll see that the nodemon command that we set up earlier will then be started by that command. And then we can go ahead and restart the container if we want to by using this restart button. And that takes a moment, but then it'll just restart the server. You can stop the container from here using the stop button, and then you can see once you've clicked start, it will have exited. And then I'm just going to go ahead and delete this container because I want to show you how this works through the terminal. So I'm going to go ahead and close or minimize Docker desktop, and in our terminal, in the root of our API, we can set up this run command. So we're going to say Docker run. Then we just need to reference the name of our image that we've created earlier. So we can say Docker run my app / express API. Remember to reference the tag. So I'm going to say : latest dev. Similar to what we saw in Docker Hub, we've got the output of our server. At this stage, we've successfully created a Docker image, and we've run that image, and we've created that container. All right, so once you see that server running there, I wanted to just show you in Docker desktop. Previously, we were in this images section, and if we head on over to containers, you'll see now we've got a container running. Up and running, and so it's based off this Express API image that we have. And you can see Docker names these containers that is once it's built the image, like it gives it some random name. So let's just go ahead and kill this container. And so there's two ways you can do this: from the terminal, or you can do it from Docker Hub. So let's just do it from Docker Hub now. We're going to stop that container. That's just going to take a moment. Then once it's stopped, you'll see it has exited with the code 137. So I'm just going to show you one thing in the terminal. So if you go Docker PS, and this is going to list out all the containers. At the moment, the PS command will only return the values of containers that are running. So we'll say docker ps-all. So that'll output the names of the container that was just exited. And we saw that through Docker desktop. And so I know we're jumping between the terminal and the desktop, but it's like there's two ways to do this, and I just want to show you both. So the point I wanted to make here is the names over here. And so last bit in Docker desktop, I'm going to delete this container. Once that's done, I'm going to close Docker desktop, and then we can say docker ps-all, and you'll see now that that container has been removed. The last little bit here is I want to rerun the command. So we've got this docker run command that we use, and so to name our container the way we want to, we can use this -- name flag, and then the next kind of argument is what we want to name it. So we can name it anything we want. We can say dev test, and then just make sure there's a space between the rest of your command. So you've got docker run -- name space dev -test, and then the name of our image that we've referenced. And so if I hit enter there, you see it starts up that container. And to show you this in the terminal as opposed to Docker Hub, it's going to open up a new terminal, and we're going to do a docker ps, and that PS is going to list out all the containers. And then you'll see we've got a container ID, we've got which image is based off some other information, and you'll see now that we have our dev test in the name. So in Docker desktop, if you head on over to containers, you'll see that that name is then what we want to name it. So if we want to stop the container from the terminal, you can reference the ID of the container, and then you can say docker stop, reference that ID, and once you've hit enter on that command, it'll just go through the process of shutting it down. Once it's successfully shut down, it will output the ID of which container it shut down. And if we do docker ps, you'll see that there's nothing running. And if we do a docker ps-a, you'll see that the container is there. And so the container has stopped. And so at this stage, the container is not running at all. So let's just head on back over to our other terminal tab. So let's just rerun that docker run command. So if I run the same command with the same name, dev test, we're going to get this error from Docker saying that there's a conflict and that name is already in use. So these are some of the tedious things with Docker. If I say docker ps all here, we can see that container is exited. And at this stage, like, we can call this a dangling container. So if you wanted to run this container again, we can just like rename it anything else. And then if we say dev test 2, and if we head on over to our terminal here, we can say docker ps all, and you can see that there's two here, dev test 2 and dev test, and this one that we've just run here it's been up for 7 seconds. It is running. So if we do a docker ps, you'll see that it is currently running, and that's all looking good. So let's just stop this container. So we can say docker stop, and we can also reference the name instead of the ID, which is just easier to reference. So we can say docker stop dev test 2. And once that's done, all the containers are stopped. We've covered a lot of work. Now let's take a short break here. In the next lesson, let's just look at some of the shortfalls that we have with Docker at the moment, because we're kind of halfway through our setup. So I'll see you in the next lesson. Cheers for now. Picking up where we left off in the last lesson, we've built our image, we've run a few containers. At this stage, I wanted to point out two kind of flaws in the setup at this point in time. The first one is we have to rename the container every time we want to run it. For the purposes of this lesson, just so it's not so tedious, I'm going to leave out the name flag in our run command. And I'm just going to allow Docker to assign random names to new containers. In this way, just for our experimentation, we can just rerun our image each time. If I do that and run that command without the name flag, you'll see our server is up and running. And I'm going to clear out this here, and we're going to do a docker ps, and then you'll see it's assigned one of those random names again. So that's all fine for now. The second thing I wanted to point out here is, if you remember in the previous module, we set up nodemon, and so we can see the output here, nodemon, and it's watching and waiting for changes to any files. And now that we're using Docker, it'll be interesting to just point this out to you. I'm sure you figured this out already on your own, but previously, if we made changes to anything in our file, our nodemon will hot reload our server. Let's just put a random piece of code in here. I'm going to use a console log so we can see the output, and we're going to say testing Docker images. I'm going to hit save here, and you'll see that we don't see any hot reloading or anything like that. And that's because Docker has bundled up our application into an image. That image has been run and is running in a container. And so when we ran the command to build the image, we kind of took a snapshot of our code base and then copied it over into that new Docker image. And then that image is run in the Docker container. And so that means that any changes we make now is kind of like forked in terms of the differences. The Docker image that contains our code base doesn't have this line of code, while our code here locally has it. So this problem that I wanted to point out, which is quite interesting in terms of, this is one of the things that helped me understand the abstractness of Docker and how containers and images work. And so I can very clearly see now I've made changes here. That image that has been packaged up is like, it's in history now. We can't expect nodemon to make changes into that Docker file. For now, there is a way to set this up, and that's coming in the next module, but I just kind of wanted to foreshadow that. The point here is just to try and like get a real grasp of like how Docker is packaging up our code. Out of interest, let's just do some more work with our Docker commands here. And I'm going to go ahead and stop this container. I'll say docker stop, and then we'll say cool DaVinci. But that'll be whatever it named your container. And then once that's stopped, we can head back to our API here. So because we've got a new piece of code, what I want to do is recreate the Docker image. And so this poses an interesting question. When I run the Docker build command here to build the image, does the previous image that we've created, which I'll just output here, does this get overwritten? How exactly does this all work? Like, this was a question that I had when I was learning this stuff, so it might come up on your side. So this is just something that I wanted to demonstrate here. I'm going to then rebuild this Docker image, and we're going to do that again by saying docker build and then -t, and we'll say my app/express API. And then we're going to give it a tag of latest dev. Then I'm going to reference that period for where we are located in our API folder, and I'm going to hit enter. Then you'll notice that we go through the same kind of output that we saw previously when we first built it. However, you will have noticed, and you can see by the timestamps that are outputted here, that this build was a lot quicker. So A lot of the other steps like the authentication, the transferring of the files and stuff like that, like 0.0 seconds, all of these layers are cached. The evidence of that can be seen in this first step here when it pulls from the node Alpine. And so it's already gone through that. And that was the longest step in our previous build. You can see it's 0.0 seconds here. And that's because Docker has cached this layer, right? It's already pulled that from the Docker hub. It's got it locally. Nothing's changed. It just kind of pulls that from the cache. So we take a closer look at the step here where we copy everything from our source to our destination. So that's copying from our local code base into the Docker image, like the working directory. You can see this only took 0.1 seconds. And so Docker uses this caching system where it creates like a differential between your local code base and the cache that it has in its memory. And it's picked up that there was only one change, and that's this change here, right? So it's only had to make one change to this file. And so instead of reloading or copying everything over, it's just like bringing over this one change. So once that's done, everything else is cached. So it's literally only that one change. So we can then take a look at our images. So let's say Docker images. And an interesting thing I wanted to point out here is you'll see that we now have two images. With the timestamps, we can see this one was the first one that we created 31 minutes ago. This one is the new one that we're taking a look at now. And just take a notice that we have this none in the repository and the tag here. So when we run this command over here, we use the same name as we did before, as well as the same tag. So what's happened here is Docker then has unlinked a reference to this previous image. It's tagged this latest image that we've created, which should include our change that we've created here in the console, and it's now tagged it with the latest dev tag. Now we know that this is the latest image that we want to use. Now that we've created this image and we understand how this is all working, let's go ahead and let's run this image. So we'll say docker run my app and then express-api and then the latest dev. If I hit run here, you'll see that we do indeed get this console log of the testing images, which relates to our work that we've done over here. So you can see the process of getting our work that we update on our local code base into the Docker image and container is quite tedious and problematic at this stage because we're halfway through our configuration. This is obviously not what we're intending for our development environment. Like, this is not convenient at all. However, I think going through this process gives you a really firm understanding of how Docker's working in the background. These are really good things to know. And so let's do a little bit of cleanup before we end off this lesson. So in a new terminal, let's just go ahead and do a Docker PS. And you just copy the ID or name, however you want to kill the container, and say Docker stop. And then you can execute that command to stop the container. And once that's done, you can do a Docker PS again, and you can see that we have got no containers running. But if you do a Docker PS-A, you'll see that we've got a whole lot of containers that are starting to stack up, and it's getting quite messy. And so let's go ahead and do some cleanup. We can do this again. We can do this via the terminal or via Docker Desktop. So I'll show you both. Just to start off with, in Docker Desktop, in the container section, you can just select whatever containers you want to delete, and then you can delete them. I'm going to ask you to confirm that. Once that's done, in the terminal, you can also verify that with your Docker PS-all, and you'll see instead of 4, we only have 2 now. Okay, so that's how you can delete containers from Docker Desktop. And you can do the same thing with images. You can go ahead and select which image you want to delete that, and then that is saying deletion failed. And you'll see this quite often because it's already in use. And so the reason is that this image ID over here is being used and is linked to these containers here. So what we can do from Docker Desktop then is delete this image, and even here, but the status says it's unused, so you can safely delete it. If it is in use, we refer this as to a dangling image. We can delete that image. So that's how you can delete images and containers from Docker Desktop. A nice and convenient way to do that. Let's just do a Docker image here just to see. And you see we've only got that one image, and we'll do a Docker PS-all. So the way we can do this from the terminal, one way we can do this is say Docker container, and then we can use this prune. And if you hit enter, it's going to give you a warning, and this says this will remove all stopped containers. Are you sure you want to continue? And you can say yes. And then you'll see it's deleted those containers. And if you do a Docker PS-all again, they are gone. Right, and so for the images, you can say Docker image prune. It's going to say it's going to remove all dangling images, and you can just say yes. And then you can see it's removed that image. And so if you do Docker images, you'll see there's nothing there. And in Docker Hub, you can see there's no more images and there's no more containers. So So we've covered a bit of work here. We've done some cleanup. Let's take a quick break here. In the next lesson, we're going to work on that last bit that we want to do and set up some NPM scripts for us. So I'll see you on over there. Cheers for now. We've done some really good work so far. We've been messing around with a lot of these Docker commands. We've been typing a lot of them into terminal. I do think it's a good thing to practice this, get used to these Docker commands, the Docker images, Docker container, or Docker PS, Docker stop, prune, build, run. Like these are really important commands to know. Yes, it's good using Docker desktop. However, you can't access that all the time in some other environments in a remote server. You're going to need to be able to do this through the terminal, and so it's good to get this practice in. As you've noticed while we're doing this, is quite tedious, like the back and forth checking, all of that, and the build and the run commands in particular are quite long commands. In our particular setup, what I wanted to do is just create some convenient npm scripts that we can use just to make this a bit easier to manage. So if we head on back over to our code base, what I want to do is we've left this console log in here from our previous test that we did. I'm just going to remove that. Hit save there. In our package.json, where we've got our npm scripts, I'm going to start working on the scripts that we want to do. So I think let's think about, we're going to need something for a build. We'll need something for run. And then maybe let's include one more to stop. And I just need to put a comma there at the end of the start div just to get rid of that syntax error. And so those are the basic commands that we want. I think just to make this a bit more specific, let's just prepend this with a Docker colon, just to make it clear that this is a Docker command. And then let's begin filling this out. So in order to build our Docker image, we use that command. It was Docker build, and then -t. And then the next item that we need there is to name our image, my app, and we'll say Express API. And just excuse my spelling error there, so just make sure you spell that correctly. And then we just need to put the tag there, which would be latest dev, and then don't forget about your period at the end there, which is the last command that you need. All right, and then obviously just make sure you saved your work. And then head on over to a terminal, and then we can say npm run docker colon build. And then you'll see the command that we've set up here gets executed. So it's exactly the same as if we had to just run it ourselves, just a bit quicker for us to do. We can do a docker images, and we'll see we've got that image that is running. So that's all good. The next command we can set up is the run. So we'll say docker run, and then we'll say my app / express API, and we'll just put on the tag there. That will be latest dev, and that's all we need to run. If I say npm run docker run, we've executed that docker run command, which has then started up our container, and you can see we no longer have that console log which we deleted. It's got the latest version of our app there. That's all looking good. And then the last npm script that we wanted to set up here is the stop. So that'll just be docker stop, and then we need to figure a way out of using an ID or a name here, and so we don't have that at this point in time, but let's just test that out and see what it does. So we can say npm run docker stop. You can see it needs to have at least one argument. So we'll just do a docker ps get the ID. We'll kill that container ourselves, so we'll say docker stop. You can put in that ID, and once that's done, we can say docker container prune just to get rid of that. You'll see our server's been stopped, so I'm just going to give us some more space here. And then we're just going to have to adjust our docker run command here, and then we're going to put in this name, and then we'll just use the name here API, because that's kind of what we're running. And so I'm going to click save. In the docker stop command, we can then reference the API name that we have then created here. So if we test this out, we can say npm run docker run, and then you'll see it has created that container which has started up. And if we wanted to do docker, then we can say npm run docker stop, and once it's outputted the name of the container and stopped, you'll see that the server has been closed down. And if we do a docker ps, there's nothing running, and we do a docker ps -a, we'll see that we've got that container which is exited. So we can quickly then just clean that up with a prune, and that container has been removed. With that, I think we've got some more scripts that we've set up, and that's looking good. Just to let you know, this is like halfway through our Docker configuration. There's a lot more we want to cover and just make this like super easy and convenient for us. As I've mentioned before, I think this is really important to go through the process of doing this, just to kind of understand the ins and outs of Docker and getting used to how it works. And so we're kind of building up this knowledge in a foundational way. So good job so far. We've done a lot of good work. We'll close this lesson off and we'll pick it up in the next one. Cheers for now. Hello and welcome. In Module 2, we started getting Docker set up in our code base. We took some time to explore some of the commands and the ideas related to containers and images. In Module 3, we're going to start turning our attention to fixing some of those issues that we spotted within our Docker setup. And so we're going to work on getting hot reloading fixed, as well as a brief introduction to Docker volume. By the end of this module, we want to set up hot reloading within our Docker container and also just take a deep dive and understand under the hood why this isn't working. And then we'll introduce the concept of volumes in Docker. And at the end of this, I really would like you to understand how we can use Docker volumes to create a bridge between our local code base and the code that is in the Docker container. Once we have that base understanding, obviously we want to be able to set these volumes up through the terminal, as well as update our npm scripts to include the new options in the command for setting up volumes in our Docker command. And that's it for the objectives of this module. This is what we want to achieve. So in the next lesson, we'll get started right away. I'll see you on over there. Cheers for now. At this point in time, let's take a moment to just regroup and understand exactly where we are in our application build. So up until this point, we've done the work to set up our Node Express API. We've installed NodeMon, as well as set up environment variables and some configuration around those environment variables. Once that was done, then we set up Docker with our Docker file, and we started doing some exploration into creating images and running containers from them. And so at this point, we can say we've successfully in a rudimentary sense, containerized our Express API. So the current overview of what our build is looking like at the moment is we've got our local environment here, which we can also refer to as our host computer. So that's whatever machine that you're working on locally. And when we started our project, it was just this Node Express API. It was the only moving part of our application. And we got this set up listening on our computer's local host port 3000. We took this one step further, and then we've used Docker to containerize this application. So within our Docker container, our Node Express API is now resides in this Docker container. And within the Docker container, the Express API is listening on port 3000. When the Docker container is run, our Node Express server will automatically start up just as we would start it up on our local machine. This is where we left off at the end of Module 2. And the problem that we were facing was that initially we had NodeMon set up in our local environment to hot reload whenever we made changes to our code base, and that would just reload the server. And when we introduced the Docker container and packaged our code into that Docker container, whenever we make changes to our code on our local machine, those changes are not being reflected through into the Docker container. And the way that we were overcoming this locally was rebuilding our Docker image every time we made changes to our code, and then running a new container. And as you can imagine, this is a very poor development experience. If you're making lots of code changes very iteratively, to rebuild your image and run a new container every time is just an absolute pain. So we have to come up with a better solution, and that's what this whole module is about. And the way we're going to use this is Docker volume. So we'll fix this problem and make a better development environment for us, but we'll also learn about Docker volumes in the process. So that's where we are, and we know where we're heading. So let's take a short break here. In the next lesson, we will start talking about how this all works under the hood, so you have a very deep understanding of that. So I'll see you on over the next lesson. Cheers for now. Hello and welcome. In this lesson, we're going to take the time to understand our problem at a little bit more of a deeper level, so we can get a really good understanding of what's going on under the hood here. And when we introduce the idea of Docker volumes and set it up, it's really going to help you understand exactly what Docker volumes are and how and why they are so useful to us. If we take a look at a quick diagram here, we have our local environment, which again is our host computer that we're working on. And we've set up our project here, this Node Docker Mongo project. And this project has two items in its root folder. And the first one is our Express API, which is a folder that contains all our files and folders for our Node application. And the second item was a Docker Compose file, which we just created and stored there for now. Before Docker was ever involved in our configuration, we would run our server just through the terminal by just using the normal the standard node command, which we set up in our npm scripts. When we ran npm start dev, which we linked up with NodeMon, we had our server listening on port 3000, and NodeMon was then listening for changes. So NodeMon was this npm package that we installed in our project, and this is a tool that listens for any changes within our source folder. And if NodeMon detects any changes, so if we write some code in Visual Studio Code and we click save, it's going to detect that there were changes, and then what it's going to do is just it kind of refreshes our development environment and it reruns this npm run start dev command, and then it kicks off our server again, and then this time it's going to reflect any changes that we made into our code base. And this all happens instantly and makes our development experience really smooth and efficient. I'm sure you know how this all works, so just bear with me here as we build up to the point that I'm trying to make. However, as we progressed with building our application, we introduced Docker into the mix, and so we've added this Docker file that contains a series of commands that Docker will use then to package our code base into a Docker image. So when we run this docker build-t command, Docker then packages up our whole code base. It creates an image for us, and this image contains a base Alpine Linux image. So it's just like a really lightweight distribution of Linux that we can use with Node pre-installed on it. And in addition to that, it contains all our files and folders and all dependency and configurations needed to run our code base within a Docker container. So whenever we run that Docker build command, you can just think in your mind that Docker creates a snapshot of our code base at a specific point in time, and whatever is in the code there will then be contained in that image. So it's like kind of once that snapshot's been taken, that's what you're going to get with running in your Docker container. Once we have those images created by Docker and they tagged with like the latest dev tag or whatever you tend to name it, the next step was then to execute the Docker run command. And what this would do would create a Docker container that's running in on our local machine. And within the Docker container, it contains all those files and folders that we have that's like comparable to our local code base, because that's like a snapshot of it. And so those files and folders are now housed within the Docker container. And within the Docker container, as soon as that run command is executed, the Docker container is going to start our application with that npm run start dev command. And the exact same way as this happens locally, we have NodeMon listening for any changes, and the server is running on port 1000. However, the key point here is that NodeMon inside the container is only ever going to detect changes for any of the files and folders that are housed within that container. So NodeMon within the container is never going to be able to pick up any changes that we make on our local code base, because this instance of NodeMon that's running is only listening to the files and folders that are within the Docker container. So essentially, when we execute this Docker build command and we tag and build an image and tag it with the latest dev, it's kind of creating like I've said, it creates a snapshot. And so when we run that container, the container is based off whatever is in that image. The problem that we're having, and this is like a visual representation of that. So when the Docker container is run, we have our npm run start dev that started listening on port 3000. NodeMon is kicked up and spun up in the background where it's listening for any of the file changes. But the problem is in our local code base, when we make any changes and rerun the build command, we can see that a brand new image is like a new snapshot of your code base is created. And so the latest dev image is now this new one, like a second one in terms of the timeline, but the Docker container that's running is still based off the image that is now the older version. And so we can continue introducing changes into our code base. Every image that's created is like a new one in the timeline. So we kind of have like a fork in the road where this Docker container contains all the files and folders from two versions or an older version of the image, and the new image that contains the changes that you've made in your code base, a new container will have to be created off that. And so even though we have NodeMon running and the application is running, it's running in an isolated environment. It's got no way at this point in time to detect any changes that are happening in your local code base. I think that's a good explanation of what's going on under the hood. I think we're very clear on what exactly is the problem. And let's introduce the solution now. The way we're going to solve this is by using Docker volumes. And the short version of this is Docker volumes allows us to persist data beyond a container's lifecycle. So we've seen that the problem is that we kind of have two instances of our code base now, and one can vary over time as we make changes, and that's like on the code base on our host machine. If we make any changes there, those changes are not being ported into the image that has been created. So volumes create a persistent storage mechanism between your host computer and the Docker container. If we think of a Docker volume as a dynamic link that we create between a folder that gets stored on our host computer, and whichever working directory that we've declared in our Docker file, Docker will then have a reference to a place on your host machine where it can store and save any data that gets accumulated while the container is running. And by creating this dynamic link and making use of it, we ensure that whatever data is created during the running of the container and the application within it will be saved to your host computer. And so when that container is stopped and then rerun, Docker will be able to re-access any of the data that was saved previously in the previous running of that container. If we do one more walkthrough of a diagram here, if we had changes here which were reflected in red, we built a Docker image and we've run that container. When that container runs, it's going to execute that npm run start dev command, and our server is running on port 3000. And Node will be running in the background, detecting any changes to the files that are stored within that Docker container. But the key thing now with a Docker volume is that it's going to allow us to create this bridge. And so these files that are listed here in our working directory will actually be a reference that is pointing back to our working directory of our local code base. So any changes that we make in our local code base there, which will be reflected in the orange, is going to then move that data across that bridge that we've created, and it's going to update the files and the folders within the Docker container. And so NodeMon will restart your server for you and reflect the new changes because the files and folders have actually changed within the Docker container. I think that takes care of the why and the what, why we're choosing to use volumes, what volumes are. But let's start turning our attention to how we actually set this up. And it's a pretty straightforward process. Once you understand the concept of volumes, a very useful tool that you can use within Docker. To set it up is super simple. All we need to do is add a -v flag to our Docker command. And so you can just remember that, like the V is for volume. And the flag's going to take in an argument where it uses the syntax of you reference a path on your host computer, which we'll call our source of where you want the data to be persisted. And then the destination will be the location within your Docker container where you want the destination of your volume. The Docker run command will then just take this additional -v option into it. And once that's set up, that's kind of all there is to it. And we will see this in action in a moment. So let's take a short break here. In the next lesson, we'll move back to Visual Studio Code and we'll get hands-on and set this up. So we have a volume created and fix our hot reloading. So I'll see you on over there. Cheers for now. We've covered a background knowledge and understanding of what volumes are. And now we're going to go ahead and set that up in our project. The next step in our project build here is to set up a volume within our Docker configuration. And we're going to do this to try and solve our problem of hot reloading, so we don't have to keep rebuilding Docker images and rerunning containers. Before we get started, you can just do a Docker images, just check if there's anything there. If there are, just make sure you've got a clean slate to work with here. Remove any dangling images if there are any. And you can also do a Docker ps-or just to check if there are any containers running or else dangling. And if there are, you can just clean them out. So let's just start with a fresh new environment here. The way we're going to set up a Docker volume is just by adding a new flag or a new option into our command. So first thing we need to do is just rebuild a Docker image. And we can do that using our npm script. So we'll say npm run docker build. And once you have built your Docker image, you can just check if that exists, and that's looking good for now. I'm going to clear out my terminal to give us a bit more space. To set up our volume, all we need to do is add an additional option into our Docker run command. So I won't be using our npm script that we created. I'm just going to use the Docker command straight here in the terminal so that we can build this up. So we'll say docker run. To create this volume, you're going to use the -v flag. This flag is going to take in a parameter of how you want to set up your volume. And so you need a source, a path to a source of your volume, which will be on your host computer, and then a path to the destination of your volume, and that'll be in the Docker container. So for our source path, we're simply going to reference the folder that we currently run this command in. So that'll just be // and then a colon to separate this argument. Part of this is we need to reference the path into our Docker container where we want the destination of our volume to be. And so we can say user/source/app. And you'll notice that this path that we've just declared here, 141 to the path of our working directory. Essentially what we've done is we've created a link from this bit of code that we have here saved on our local machine. We'll link that up to the working directory that we've set up within our Docker container. And let's just continue on with that command here. I'm just going to add this name option here. We'll call this API. Then we'll need to reference the name of the image we want to build this from. So we'll say my app Express API, and then that'll be latest dev. And I'm going to go ahead and hit run here. Upon successfully running the container, you'll see that we have the output of our Express server that's been started up. We have Node1 watching, and we have our server running on port 3000. We can test to see if this volume has been set up correctly by trying to make a change within our Node server. And so let's just create something here, and let's just add a very simple word to our console log here. We'll say test server running on port 3000. You can make whatever change you want. I'm just going to go ahead and hit save here. And you see, as I hit save, you'll see that the changes are now being reflected. You'll see this test has been removed here, and it kind of happens instantaneously. And so now we've got this bridge set up. We've got this dynamic link created through this Docker volume, and that's going to make local development a lot easier. And so if we wanted to test again, we can just remove test, hit save, and you can see how quickly this happens. It's like we're running it on our local machine. This is very handy, and we've solved our problem of hot reloading now. And just to kind of take a little bit more of an exploration here, we can head on over to Docker Desktop, and you can see we've got our My App Express API image. We've got our container which is running, and we can just open that up, and you'll see the logs of our server that is running. What I wanted to show you here is that if you go over to the files section here in Docker Hub, you'll see that these are all the files that are within your Docker container, all the operating system files and folders. If we head down to our user folder here, which is our working directory that we've created, if we open that up, so we'll have our user, source, and our app over here, you'll see that we have this note here in Docker Hub that it says there's a mount, a bind mount, and this is telling us that there's a volume that's been created. And so any file or folder that is contained within this app has been mounted to our local host when we ran the Docker container, and that's linked directly to our local code base. So any change that we make in here is going to be reflected instantaneously. So that's just interesting. You can go and explore how that all works and play around with it. The last thing that we need to do here is just head on over to our package.json, and we just need to update our Docker run script that we have over here. And so we have Docker run and then -- name. Just before there, we need to add our -v, and then we want to put in our local directory here, and then we will reference the /user/source/app. And once that's updated, you can just save your work here in the package.json. And let's go ahead and stop this container. And so we can say Docker stop, and then we'll just reference the name of the container, which is API. Then we'll just do a Docker RM API, and then if we do a Docker PS-A, we'll see that that container has been removed. Let's just test our npm run command here. So we'll say npm run docker run, and you'll see it has started up correctly. And let's just test if our hot reloading is working. I'm going to hit save there, and we can see that everything is working perfectly. So that's looking good. I think we've covered a lot of conceptual work here. We've done a quick change to our code base here. That's going to make our development environment a lot smoother. The Docker volumes are also going to come in handy when we start working with MongoDB. But for now, we've solved our problem, and we can continue on with our work in our code base. So let's take a short break here. I'll see you on the next one. Cheers for now. So this is a wrap for module 3, where we've set out to set up hot reloading in our code base with our Docker container. We went through a bit of a deep dive into what volumes are, what problem they're solving for us. We've updated our npm scripts. We understand how to use or set up a volume using a Docker command through the terminal. So we've covered what we've set out to achieve in the beginning of this module. In the next module, we're going to start looking at solving some of our network issues and introducing the idea of networks in the world of Docker. So I'm looking forward to working through that with you. And so I'll see you on over the next module. Cheers for now. Hello and welcome back to module 4, where we're going to be exploring Docker networks. And to get started, we're going to go through the objectives of this module, what we want to achieve by the time we finished all the lessons in this specific module. The first thing that we're going to do is add some code to our project in order to add a test route that we can create a GET request to. We're going to call this ping. And once we have that set up, then we want to go ahead and test that this ping route works without the Docker setup. So we'll just do a normal startup of our server. The next step is we will then try and test that test route with the Express server set up within a Docker container. And then we're going to explore why we can't make a GET request and explore the error that we come across when we attempt to do so. And once we come across this error, then it gives us an opportunity to take a deeper dive into Docker networks and just take a little bit of a look under the hood as to how they work within Docker. And then we'll go ahead and update our Docker run command to make use of networks. And once that's done, we should have resolved the network error that we came across while testing our API. So that is what we're setting out to achieve in this module. In the next lesson, we'll start doing the work to cover all of these objectives. So I'll see you on over there. Cheers for now. The first thing that we're going to do is write some code, and we're going to add this to our server.js file. We're going to just set up a test route that we can make use of, just to create a GET request and start testing out our API. To get started, make sure you have a terminal open with the location at the API folder of your node.mongo project. We're going to go ahead and start up our server just using the normal nodemon command. We're not going to be using Docker, we're just going to be using the standard node command to start our API here. So we'll say npm run start and then :dev, and then you're going to hit enter and just make sure your server is running. We've got our hot reloading working there. Within our server.js file, I'm going to add a bit of space here so we can start to work, and this is where we'll be creating our first GET endpoint. The first thing is I just want to make a note for us saying that we should eventually abstract this to a router. I personally don't like polluting this kind of file with all of the routes. Like, as there's more and more routes that you add to your API, this can get very messy. So to me, it's better just to abstract this to a separate part of your code base. But for now, just testing purposes, let's just work within this server.js file. So we're going to be adding a test route here just to start tinkering with the networking and how this will work with Docker. Let's write the code to this. We're going to say HTTP server, and we're going to use this get keyword here, and this is going to take in a string that will be a specific API endpoint that you want to do. And for now, I'm just going to create this /ping route, and then this takes in a callback function with 2 arguments. For now, we can just say the request and the response. And I'm just going to set up a simple console log here. And I'm just going to write something here that we can then take a look at in our terminal. So I'm just going to say ping route, and then I'm going to use some string interpolation. I'm going to print out the request.url as well as just a timestamp, just so that we can see the order in which these requests come through. If we hit this ping endpoint, we'll see this console log. And then the last thing I want to do is just finish off this response or the request response cycle. And we'll do this by saying res.status. We'll just give it a response of 200, and it's going to end that response cycle. And I'm just going to add a JSON object here, and we'll just put a message in. And we'll say pong and then test successful here. I think that's all we need at this point in time. You can go ahead and save your work. In order to test this out, there's a couple of ways we can do it. You can just go ahead and open up a tab in your browser. Because it's a GET request, we could just use a normal browser to this. So we can say localhost, and we can reference the port, which is 3000. And then we'll use that /.ping to hit the ping endpoint. And so if I hit enter here, it's going to make this a bit bigger. You'll see that we get this response message, pong test successful. And so that we know that we're getting the response. And then we can also see in our console or in our terminal here that we've got, which is dumping out the console log, we see that the ping route was hit successfully. So this is very simple stuff. We've got our first API route set up. We know that we're getting a 200 back, and so we can verify that on our local host with a standard node setup and express setup, our API is working fine. So let's go ahead and start this up using Docker. So I'm going to kill our server, just clear out the terminal. And I've gone ahead and I've cleaned out all the Docker images and containers on my machine. I want to start from scratch here. So even though we have got the volume set up, I'll just be recreating the Docker image from scratch. So we can do this using our command. We can say npm run docker build. Give that some time to do its thing. Once that's complete, we can go ahead and use our command npm run docker run. Once that's run successfully, you'll see that we have got the output here of the Docker container. They're just telling us that the server is running on port 3000. So now at this stage, you can go back to your browser, and I'm just going to open up a brand new tab, and we're going to try hit localhost 3000 /ping. And if you try to ping your API on localhost 3000, you're going to get back this error here where it says the site can't be reached, and you're going to get the specific error saying error connection refused. And this was a specific error that we are leading to here. So we can introduce the concept of networks in Docker and how we can adjust our Docker command to make use of networks to overcome this issue. And so let's take a short break here. In the next lesson, we'll take a deeper dive and understand what's going on here. So I'll see you on over there. Cheers for now. In the last lesson, we wrote some code in our API to set up our first endpoint of our ping route that we wrote a request handler for. We verified that it was working in our local, or on our local host rather. And we did an additional test using Docker, and we saw that we got that error connection refused in our browser when we attempted to do a GET request to our API. And so to understand exactly why we get this error, we're going to take a look at Docker networks. And this is a feature of Docker that gives us a seamless way to implement container connectivity. If you're using multiple containers that need to speak to each other, or if you need to speak to your container from your local machine, there is a way in Docker to do this. And so we're going to take a look at this and set it up within our Docker configuration and our Express server. The first thing is just to reiterate what's going on here. We have our localhost environment where our Express server is running on. And so that's whenever we do npm run start dev, we're just starting up node on our local machine. When that happens, as we've seen before, we get our server, which is listening on port 3000. And the important thing to take note of here is that this port that is exposed was listening for traffic on the network is within the local host. So that's on the computer or the machine that you're working on. And so now that we've implemented that ping endpoint, when we make a GET request to that specific endpoint on port 3000, everything's working fine. We're seeing our console logs being logged out. We get the response back. Everything's working fine. And so to reiterate here, it's the port 3000 is exposed on our local host, and this allows us to send a request to our Express API on this specific port, and we can initiate that GET request on port 3000 and we'll receive response. So the whole request response cycle is working within our local host environment. The problem that we're facing is within our local host environment, if we spin up our API within a Docker container, even though the Express server is running and listening on port 3000, it's isolated to the Docker network that is created when our Docker container is spun up. And so by default, Docker does not expose any ports on any networks. It does have a network by default that it is running under the hood. It's not exposing any ports to allow traffic to come through into the Docker containers. When we try and do a GET request to that ping endpoint, what's happening is on our local machine, the curl command or the request is trying to find a port on the localhost 3000 which isn't exposed because we haven't run our server technically. That server is isolated within a Docker container, and so that's kind of in its own separate world. It's not accessible by our local host, and therefore when we try and make this request, we get that error connection refused. So as I mentioned in the beginning of this lesson, Docker has a set of feature and tools that we can do a lot of useful networking jobs with. Within our Docker configuration and the way that we run our Docker container, we can adjust the Docker command to expose a specific port on the network that is created when the Docker container is spun up. And so what we're going to do is we're going to map port 3000 on our local host to port 3000 within the Docker container. So once we've kind of created this bridge where the exposed port in the Docker container has exposed 3000 and we have local host mapped to that port, we'll be able to direct any traffic from our local host through to the Docker container, which is listening on port 3000. Once we implement this will resolve the error connection refused problem that we've been getting when we try and hit our ping endpoint. And so once we've implemented this and we try and do that GET request to the ping endpoint, it's going to try and hit localhost 3000. It's going to pick up that there's a rule that we've written or we've mapped port 3000 to port 3000 container. So then it's just going to route the traffic through to that port 3000 in the Docker container. And the server is going to receive that incoming request. It'll then process it as it usually would as we have defined within our API. I'm hoping that makes sense. A very short version of this is we're just going to create a mapping between our localhost port and the port in the container, and this will allow us to communicate from our localhost into the API container as if we were making these kind of requests from our local machine. And so I've mentioned that the way that we expose these ports is by updating our Docker command. And we can do this with the -p flag. And so we simply need to add the -p flag, and then it takes in this argument which has a specific syntax. It'll take in a number which corresponds to the port on your host machine, and then colon, and then it'll be the number of the port on which you've specified within your container. So if we take a look at a sample of our Docker command that we're going to be implementing, it'll be docker run -p 3000:3000. So the first 3000 is the port on your local machine. The second one is the port within your container. And so that creates that bridge, or it maps those ports together. And then the rest of the command, which will be the name of your image, the name of your project, as well as a tag. Try and remember the syntax. The host port comes first, and then the container port will always be listed second. So that's a brief look at understanding what we're trying to do with Docker here to overcome the error that we've come across. Let's take a short break here. In the next lesson, we'll actually do the work to update the command and explore that with a more hands-on approach. So I'll see you on over there. Cheers for now. Now that we understand exactly what we need to accomplish here with updating our Docker command, let's go ahead and do that work. So previously we've started up our Docker container based off the image that we built, and it's still running in my terminal here. In a new terminal, I'm just going to say docker stop API, and I'm just going to let that container exit the process so it's not running anymore. So we'll leave the Docker image that we've built as it is because we haven't made any changes. We just want to update the command that we used to run the server. So in our package.json, you can see our docker run command here. That npm script will map to the specific command that we use to run our Docker container off the image. All that we're going to do is update this command here. And so after docker run, I'm just going to add this -p flag. Remember, we're going to map the port on our localhost 3000, and we want to map that through to port 3000 within the Docker container. So that's pretty much all you have to do. You can just go ahead and save that in your package.json. Remember, there needs to be a space between your -p and the 3000:3000, and another space between your next command. Once you've saved your work, you can say npm run docker run. I do get this error with the naming conflict, and so let's just go ahead and get rid of this container. So we'll say docker container prune, and I'll say yes there, and I'll go back and we can rerun this command. And you'll see now that in our terminal output here, you can see that the docker run command has been updated with our port 3000, the mapping that we've created there. The server is up and running within the Docker container on port 3000. And so let's go ahead and test this. You can open up your browser that you've been using, and I'm simply going to reinitiate this request. So we'll say localhost 3000/ping, and you can see if we hit this endpoint now, we successfully get the response here that it was successful, and we also see the terminal output within the Docker container that this ping route has been successfully hit. So with that small update that we've made to our Docker command, we have now bridged across the network of our local host into the container or the Docker container, and we are able to route traffic from localhost to our container. So that's all looking good. And if you wanted to verify this, you can just go to your containers in Docker Hub here and just click on it, and you'll see that you do see the same exact output in the terminal here or in the logs. So you can verify that the traffic is coming through to the actual container. Right, so that's pretty simple stuff. I think there's one more thing that I wanted to show you here is in a new terminal. I just wanted to say in a new tab in your terminal, in a fresh kind of console here, I wanted to show you this command where you can say docker network, and then you can use the ls command. And if you hit ls here, you're going to see a list of all the networks that Docker has running locally. And you'll see this network here named bridge, and the driver is bridge. There's this one with host and none and null. Let's take a closer look at the bridge network. So you can say docker network inspect, and then we'll say inspect the bridge. If you hit enter on that command, docker network inspect bridge, you'll see that you get a whole lot of information related to that specific network. You can see the name is bridge. It's got an ID when it was created, the scope, which is local, the driver, which is bridge, IPv6 is disabled, so that's set to false. And there's a whole lot of networking information, like really under the hood stuff, but interesting stuff to take a look at. And you can see that it's got a key here with containers, and this lists out the containers that's connected to this network. At this point in time, we just have our API container, which is attached to this network, and it's got an IP address as well as a MAC address, and then some other options. But the main thing that I wanted to show you is this containers tag here. And eventually, when we start adding more and more containers, maybe for a MongoDB, which would be a separate container, we'll then be able to attach those containers onto the same network. Once we have that, we'll have the ability for containers to be listed on the same network, so it can, or they can speak to each other on the same network. So you can take a look at that. There's just another way to inspect the network. Just another command that you can add to your Docker toolset. So that's it for this lesson. Let's take a short break here. I'll see you in the next one. Cheers for now. At this point, we have covered all the objectives that I set out in the first lesson of this module. We've implemented a test route, that ping route handler that we implemented in our API. We've tested that on our local host and our local environment. We came across that error connection refused. We understood why we get it. We took a quick look at Docker networks, as well as how to update our Docker command to make use of the network and bridge a connection between our local host port 3000 and the port 3000 within the Docker container. With all of that, that resolved the error that we were getting, and we are now able to successfully hit that ping endpoint within our API that's isolated in our Docker container. And so with all that being done, that concludes our work for this module, where we took a quick look at Docker networks. I hope this all makes sense so far. We've been taking a very iterative approach here, one step at a time, just trying to understand how Docker's working step by step and building up to this big command that we've now created which has a couple of different flags in it. And hopefully at this point, when you see this kind of command, it all makes sense to you, understand exactly what each one does. So with all of that set up now, our Docker configuration is looking quite stable in terms of like being ready for our development environment. There is one last step that I wanted to go through to make our life a little bit more easier with Docker. And so in the next module, we'll take a quick look at Docker Compose and how we can set up our Docker Compose file that we've created, but we haven't written any code in it, or we haven't configured yet. And so we'll do that in the next module. I'll see you on over there. Cheers for now. Hello and welcome back to a new module. It's going to be a quick one. It'll be a short one. It's going to be the last little work that we're going to be making to our Docker configuration. And as you've noticed, we've been building up this Docker knowledge through a very iterative step-by-step process. And one of the reasons why I've chosen to do it like this is so that it kind of sinks in this point that managing Docker containers and images the way that we've been doing it with the Docker run commands and build commands is not very sustainable or efficient for development environments. And at this stage, we're only working with one single Docker container. In a few modules time, we're going to be introducing MongoDB, and we're going to be isolating that in a separate Docker container. And then at that point, we're going to be working with two containers. And so then we'll have two images, two containers, and the coordination and working with these two separate containers is going to be a bit of a mission in terms of using these Docker commands that we've set up, especially as at this point in time, our NPM scripts that we've even set up only relate to one single container. So it's a perfect opportunity to introduce the idea of Docker Compose and why Docker Compose is useful. And it's going to be the final piece of the puzzle in terms of how we're going to be setting up our API in this course. Very simply put, when you think of Docker, or when you hear Docker Compose, just think of container orchestration. And you'll come across this a lot in documentation and other learning resources online. But just Docker Compose is the way that we can coordinate and orchestrate the work that needs to be done between multiple different containers. This will make a lot of sense once we start working with it and we're working with more than one container. But for now, just understand that definition. It's going to make a lot of sense later. And so one of the other questions is, why do we even want to use Docker Compose? And for me, there's three important reasons. The first one is simplicity. As you may have noticed already, our Docker run command was getting quite large with the port flags, the volume flags, as well as the name and tags of our images that it needed to run. And typing this out each time, even though we had the convenience of an npm script set up, there's a much easier way to do this and a much simpler way of doing this with Docker Compose, where we can write out this configuration in a YAML file, where it's easier to read, easier to maintain, and once you just use the Docker Compose command, it's going to ingest that whole YAML file and execute the commands behind the scenes instead of typing out these long, clunky Docker commands, which it's very easy to make mistakes with. The second reason would be consistency for me. If you're working in an environment with many different developers, we can have one standard way of implementing and executing our Docker commands and our Docker setup, instead of relying on each developer or member of the team kind of setting up their own Docker run commands. We can just have a single YAML file that can be executed, and this can obviously be committed to source control. And so everyone has a copy of this file, and with one Docker Compose up command, we can just execute all those commands, and it makes it a lot more consistent across different environments. And the last major reason for me is flexibility. Once we start introducing more than one container, it's going to be so much easier managing all of the configuration, all the volumes, the networks, the ports that we're using, the names of different containers, and the orchestration between them in one single file, in one place in your code repository. And so this is just going to give us a very easy way to kind of extend our Docker configuration as our application or our setup gets more complex. Right, so that's enough talking about it. Let's head on over to our Visual Studio Code so we can start implementing the configuration for Docker Compose. Before we begin setting up Docker Compose, just a note from my side, I've gone ahead and cleared out all the images and containers from previous builds in the previous modules. So if I do a Docker images here, you'll see that there are no images listed here. And if I do a docker ps-all, you'll see I've got no container. So that's how where I'm at the moment. You can go ahead and kind of clear it out on your own if you need to, just to avoid any complications down the line. Next step, you can go ahead and head on over to your docker-compose.yaml file. This is a file that we created way back in our first initial setup of our project. We said that we'll come back to it, and now we are going to be doing the work to set this up. So the Docker Compose file is a YAML file which uses standard YAML to set up our configuration. So it kind of follows a key value pair with indentation in your file that will kind of allow you to nest under certain headings or certain keys that you're using. So I'm just going to go ahead and start writing out this compose file. I'll talk you through it a bit as we go, but we'll also at the end just take one deeper dive into each specific line in this file that we create. The first key here that we're going to have is a version, and we're just going to specify 3.8. At the time of this recording, it's the closest version of Docker Compose that matches to the version of Docker that I'm running. And the next key here that will be on the same line as version will be services. And this is going to be kind of like a nested setup here where each service will be a key. So the first service and the only service that we're running is our API. So I'm just going to go ahead and name this API. And then under the API level, then we can start listing out some configuration for our API. The first one that we can use is this container name. And we're just going to name it API like we have been doing. And the next key here is the build key. And this is just going to specify where the location of our folder is, where the Docker file is kind of residing. So as you can remember, the Docker file in our API lives on the API level here. So we can just say /API, and then it will know to look for a Docker file within that folder. And I'm going to add a key here, which says restart. And I'm going to give it a value of always. I can explain this in a little bit more depth later, but for now, just understand this is a flag that we just telling the Docker engine that if for any reason the API container exits with the container 0, it should just restart it because the service should always be up and running. The next key that we can use is this port key, and so I'm going to use a dash here, and in strings I'm going to say 3000. And 3000. And so if you remember in our Docker command with the -p flag, the host container always goes first. So we're looking for port 3000 on our local machine. and we're going to map that to port 3000 within our Docker container. And the last thing that we need to set up is the volumes. The same way that we did with our Docker command, we just need to recreate this. So the way our volumes is set up is we want to make a reference to the API folder. Then we want to map that to the user source/app, which is the working directory in our Docker container. And remember, that would be specified in the Docker file here. And so that relates to this working directory. And I'm going to go ahead and save our work here. With that, all of our configuration is set up for this container. And so if you think of it in one way, it's just like breaking up that long Docker command that we've been using, which would be this one over here. We've kind of like broken it up into a easier to read YAML format. You can see the ports are specified here, the volumes are specified. We've got our name, where the Docker file is, and then we can start adding additional flags or configuration in our services. So once we have that YAML file set up, we can go ahead and test this straight away. In all previous lessons, we've been working within the API folder. And now that we've set up Docker Compose, and this is an important step, so make sure that you do it, you just need to change directory to go back one level so that you're in the node Docker Mongo or whatever you've named your project. And so just make sure that if you do an ls, you can see the Docker Compose.yaml file is there. Just to show you what would happen if you, in the root of your actual project where the Docker Compose file lives, you can say Docker Compose up. And if I hit enter here, it's going to set up our Docker environment the way that we want it configured. So once I've hit enter there, it's going to take a while for this to be set up. And you can see it's going to go through the same steps as when we build the image and then run the container. And you can see the output of this Docker Compose up command. There's some additional here where it's created a default network, and it's gone ahead and done that for us already. And then we've got our container API, which is up and running. It's attached that container API to the network, and our API is up and running here. So if we go ahead and test this out on our local host, we'll do localhost 3000/ping. And you'll see that everything is working correctly with our Docker Compose app command. With this configuration that we set up, we just need this one command and then everything is up and running. And if we want to stop the server for whatever reason, we can just say Control-C. We can just say Control-C in our terminal, and then it's going to go ahead and gracefully stop your container for whatever reason that you wanted to do that. And then once that's exited, that container has now exited and is cancelled. So if I do a Docker images, you'll see that there's that Docker images with the latest tag. We'll do a Docker ps-a, and then you'll see that we have the node Docker Mongo API, which was running a few seconds ago, and then API names there. So it's like everything that we were doing with our previous Docker commands is now being accomplished through this Docker Compose file. So there's one quick thing that I wanted to show you here is just to reiterate the ports on our computer. Let's say that we change the port that we're mapping, so we want all traffic from localhost 3009 to map to our Docker container. We can just go ahead and change that in our Docker Compose file. We can just use that Docker Compose up to rerun our container, and you'll see that it's been recreated. And then our Docker container API here is listening on port 3000. So if we go ahead and try and hit that localhost 3000 /ping, you'll see that we can't reach it because we've changed the mapping. So if we wanted to change the mapping on our local host here to 3009, and now if we hit enter, we'll get a success because we've just changed the configuration slightly so that it's a different port. But by convention, normally we just kind of use the same port number, even though sometimes as a beginner it's a bit confusing, but it makes a lot of sense just to keep it the same. But for whatever reason, if you wanted to change that, you can see how quick and easy it is to do that using Docker Compose. Right, so that concludes this module on Docker Compose, as well as an important checkpoint in our API setup here. We've kind of finished all the Docker configuration that we've needed to do, and we've covered some theory behind it, some deeper understanding. And so in the next module, we'll be moving on to a new topic, which would be setting up MongoDB. And now that we've got all the foundations laid for Docker, it's going to be a lot easier to set this up in its own container. And then we can start looking into some more of the nuances and the topics related to MongoDB. So looking forward to working through that with you in the next module. I'll see you on over there. Cheers for now.